In question 11, we have to fill in the blanks in each of these 6 statements. Alright, so in part 1, the statement says 0 has dash reciprocal. Now the number 0, if you take its reciprocal, you will get 1 by 0, which is an undefined quantity. It is not mathematically defined. So we cannot take the reciprocal of 0. So we can say that 0 has no reciprocal. Statement 2 says the numbers dash and dash are their own reciprocals. This is something we discussed in the previous question of this exercise also. There are exactly 2 numbers which are their own reciprocals. And those 2 numbers are 1 and -1, because the reciprocal of 1 is 1 by 1, which is 1, and the reciprocal of -1 is 1 by -1, which is again -1. And if you take any other rational number apart from 1 and -1, if you take any other non-zero rational number, the reciprocal will be different from the original number. So the only numbers that are their own reciprocals are -1 and 1. So that completes statement 2. Now in part 3, the statement says the reciprocal of -5 is dash. So the reciprocal of -5 will be 1 by -5, which we can also write as -1 by 5. So the blank in part 3 will have -1 by 5. In statement 4, part 4, the statement says reciprocal of 1 by x, where x is not equal to 0, will be what? So the reciprocal, so we know that the reciprocal of x is 1 by x, because x into 1 by x is 1. So if you just from the same relation, you can observe that the reciprocal of 1 by x will be x, because 1 by x into x will also be equal to 1. So we can say that the reciprocal of 1 by x will be x, and this is because 1 by x into x is equal to 1. Now in part 5, the statement says the product of 2 rational numbers is always a what? So basically the set of rational numbers is closed under multiplication. This basically means that if you multiply any 2 rational numbers, so let's say p by q into r by s, you will always get a product which is rational. It will always be a rational number. So we can say that the product of 2 rational numbers is always a rational number, and the reason is that the set of rational numbers is closed under multiplication. Finally, in part 6, the statement says the reciprocal of a positive rational number is what? Is blank. So take any positive rational number, for example, take 3 by 7 and take its reciprocal, you get another positive rational number. In this case, you get 7 by 3. So take any positive rational number, its reciprocal will also be positive. So the reciprocal of a positive rational number is positive, and this is how we can complete the statement in part 6. So with this, we have completed all the 6 statements of question number 11. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.